Okay, friends, we're going to take a look at number 17. I know that that can be a tricky question for you, and I know some of us weren't able to make class today for a variety of really good reasons, so I thought I'd take the time to just do a quick video on this guy. Please pause the video right now and try this problem. Set a timer for, say, 10 to 20 minutes. Try it on your own so that you know why this question is so hard. Otherwise, I'm going to make this look relatively straightforward. Okay, so there's a woman. She's walking along a flat ground, and she's walking toward a lamp. And this is a really good lamp if you think about it. And it's 11.5 meters tall. So I'm going to record that. That's how tall it is, and it's a constant height, so it's not growing. And the woman is also not growing. Here's the woman wearing a wonderful pantsuit, and there's her very short hair, but very, very dignified hairstyle for sure. And she's 1.54 meters tall. Okay, so that's the situation. And obviously, as she walks towards the light, there will be a shadow cast behind her. And so let's make sure we can make sense of that. So we have a woman, and she's walking at, 53 centimeters. So I'm going to turn this to meters, 53 meters, 0.53 meters per second. Excuse me. And so this distance right here, from here to here, we're going to call W, because this is what she's doing, and she's moving in this direction. Excuse me. As she moves, behind her, there will be a shadow. So that's why I have those two. So let's see what other information is given. At what rate is her shadow length changing? So we're trying to find this value right here. Okay, and let's see what we've got here. So, and it says that the question is, how is this rate changing when she is 19 meters from the wall? So I'm going to put an asterisk by that, because we know we can only put that value in after we take the derivative, because a derivative finds the instantaneous change at a particular moment in time. So if 19 and 20 could be different, and is different in most situations. Okay. So what we're going to do now is we're going to write down what our variables are. So we have S prime, W, W prime. And I just like to do this so that I can see it clearly. So I don't know what that is. I definitely don't know what that is. Okay, and I know what that is at a moment. Okay, and then it's this part here that I do know, and that's, that's a decreasing. So that should be decreasing because it's a decreasing value. That should be a decreasing velocity. Now, what I want to do right now, this is a spot where many people would, so this is a spot where many of us have gotten more comfortable with, okay? So we've got to that point. And so what you've gotten really good at, and it's time now for you to really consider, 1B, speaking clearly to the fact that you can represent mathematical ideas in concrete, pictorial, and symbolic forms. So in this example here, we've certainly done pictorial. We've drawn a picture, and then symbols are going to be the equations and the numbers and all those things that we put together in that. We're also going to look at 3D over here, that you can model mathematical situations. So you're going to be able to represent a problem or a scenario, real, and this one is real, in a visual form that can be used to solve a problem. Okay. We also are going to maybe want to be able to explain why we're using the tools that we're using. Another one I like to highlight for this one, this is the part that many of us are really having trouble doing. Develop, demonstrate, and apply conceptual understanding of mathematical ideas through inquiry. So right here it says, use noticing and wondering to determine what is needed to make meaning and solve problems. So let's go back to it. This is where most of us are blocking. And I had a conversation with someone going down the stairs today that this is what we need to work on. And it can be a bit stressful because you're like, how do you learn? How do you notice and wonder? And I don't think there's an easy answer for that. It's just as simple as just trying to notice and wonder. So let's look at this. Somehow we need to connect these variables. Okay, so in order to connect them, we have to notice and wonder. We have to say things like, what do we see? Do we see any shapes? Are there any formulas that we know? Like, is this an area question? Like, is there anything that would lead us to think that we're trying to find the area? So like a half base height, or is this a Pythagoras question? Are we interested in the hypotenuse? These are certainly right triangles. I think if you notice and wonder long enough, you're probably going to go, hey, wait a second, I see triangles. And if you see triangles, you are right. There are definitely two triangles there. So let's label them. Let's not make any judgments quite yet. This distance here on the smaller one is 1.54 meters. This is the woman's shadow. Okay, so and this is 90 degrees, and this is 90 degrees. And this little angle here is the same for both triangles. So if you have two angles that are equal in two triangles, then the third one has to be equal because angles in a triangle add to 180. In the larger triangle, I know what this distance is. This is 11.5. Let's see, this lower distance, it's going to be really tempting for you to say S plus 19. Okay, that's going to be a common error. You should pause the video right now and think, why is putting 19 right now a problem? Okay, so I trust that you know that you can't put the plus 19. And the reason for that is if you put 19 in, that means the woman is standing still. And the question clearly says the woman is walking toward the lamppost. So we know we need to leave room for that distance to change. And that's why we go S plus W. So we got to go back and let's look at this. We got to go noticing and wondering. Use noticing and wondering to determine what is needed. So we looked at this and you just got to take some guesses. And remember, you have to be willing to say, I bet there's a lot of ways. So that allows you to try this pathway. And if it doesn't work, try another one. That's what real problem solving looks like. Okay. So when I look at this, I'm thinking, okay, I got two similar triangles. The 1.54 corresponds to 11.5, and I'm trying to figure out how quickly is S prime changing. Okay, so what I'm going to do it over here where I have a bit more space. I'm going to go S over 1.54 has to be the same as S plus W over 11.5. And then we have to say, hey, is this what special triangles say? Like these have to be proportional, right? Like the height to the base has to be the same as the height to the base. Other people might have said, could I have gone S over S plus W equals 1.54 over 11.5? And if you look at this, when we cross multiply, it's going to be S times 11.5. Oh, S times 11.5. S plus W times 1.54. 1.54 times S plus W. Perfect. So I'm going to cross multiply. So I'm going to have 11.5 S equals 1.54. Notice I'm making my S's bigger just so that I don't get them confused with fives. 1.54 W. Okay, so here's my equation. Okay, so at this point here, it should be relatively straightforward. We are going to go, the only challenge now is if I can do that calculation, that subtraction. I don't have the calculator nearby. So you guys are going to get to watch me go 11.5 minus 1.54. Oh boy. So that's going to be 6. That's going to be 9. That is going to be 9. I think that's going to be 9.96. I hope I'm going to just check and make sure. So 10 minus 4 is 6. That's going to become a 14. 14 minus 5 is 9. That became a 0. Perfect. So we're going to have 9.96S equals 1.54W. That's our equation. Take the derivative. That's going to be 9.96S prime equals, and remember by S prime, we mean the change in S over the change in time. Okay, the question says that the shadow's distance is changing compared to time. So when we're using S prime, that's a notation we can use, but you should be clear in your mind that that's what it means. Then we're going to have 1.5. That should not be a plus W, by the way. That should be 1.5 W. Okay, and so then we're going to have 1.5 W prime. We're going to look back, and we're trying to find S prime. Oh, and we know W prime. So I can solve this. I can go S prime is going to equal 1.5 times negative 0.53 divided by 9.96. We're going to press equals, and that's how we answer this problem. So there are lots of people who go, this is so hard. And of course it's hard, because this is problem solving. Problem solving is not easy. And if you have been directly taught how to do all the problems and then you repeat them, that's not problem solving. That's getting right answers on tests, which has its place, but that is not problem solving. Okay, so let's just talk about what the themes were here. What we did first is we read the problem. We attempted our best to model this situation. So that's what we did first. So we did a modeling of the situation, and we didn't move on until we understood what was happening. As the woman walks closer to the lamp, her shadow is going to decrease. And then we labeled it as best we could. And then from there, we wrote down the variables. And this is the hardest part for most of us at this stage. Most of us have improved dramatically in our modeling and our representing and translating from pictures to variables. What we're having trouble on, literally, is 4A, which is noticing and wondering, or that piece of being curious and wondering and exploring problems. That's what we're having trouble with. And that's not easy. That happens by practicing and doing, asking lots of questions. And my question was, what do we see? And I see two triangles. Maybe, I don't know what else you see. I don't know what else there is to see. There aren't a lot of options here. There's no circles or squares or anything. So there's two triangles. And so we labeled them. So we drew the picture. We noticed. And then from here, once we know what special triangles, we're into formula land. And once you're in formulas, this is a skill that was practiced multiple times in your past. So it's not a new skill, but it might be one you need to brush up on. And then we just walk through it and solve. And so there you go. That's number 17 on Goformative.